Well, I would like to welcome you all today to our webinar, Building and Managing RESTful API with Django REST Framework. We have the pleasure to have one of BEON experts, Matheus. I would like to introduce you to him. After graduating in computer engineering in 2014, Matheus embarked on his journey into the world of Python in 2016, where he discovered his true passion. So we're really glad to have you with us today, Matthew. Thanks. And I will leave the floor to you so we can start.
Thank you, Belen. Okay, so this is what we are going to talk today on this webinar. First, we'll start taking a look on what's an API and how it works. We'll also take a look on REST principles and how we can build RESTful APIs. The last step is to take a look on how we can build a good API code using Django REST Framework. So let's start taking a look on what's an API. API is the acronym for Application Programming Interface. It's a set of rules that systems use to communicate between themselves on the web. On this type of communication, we have two sides. The first side is the client. That is the user who wants to access some information. On the other side, we have the server. The server is the one that provides the information requested by the clients. This information is transmitted as a resource. So the information that applications provide to those clients are identified as resources. Let's talk a little bit about REST now. What's REST? REST is the acronym for Representational State Transfer. It's a set of architectural restrictions and a guideline to manage communication. So it's not a standard and it's not a pattern. You can implement it on your own way, but you need to follow this guideline. So when we have one API that implements REST principles, we can call this API RESTful API. So here we have the REST principles that we need to implement on our APIs. The first one is uniform interface. We also have statelessness, layer system, cacheability, and code on demand. On the next slides, we're going to see a deep look on each of those principles. So let's start with the uniform interface. This principle is fundamental to any RESTful application. It defines the way that the server will transfer information to the client using a standard format. This way, both sides will know how to deal with this information. This principle has four constraints. The first one says that the request should identify the resources. What does this mean? This means that when we have the URI, for example, if we have an API for a library and we want to identify the resource book, we need to have one endpoint, for example, library/book. So also, when the clients have information in the resource representation to manipulate it. This means that if we get a book from this library API, we should have on this resource representation one way to get this information to manipulate it on the server. For example, if you send the ID of the book, the client can use this to do an update or a delete on this book. We also need to send this self-descriptive messages to the client. So when we return the message about a success, or if we have any error during the communication, we need to send a self-descriptive message so the client knows what's happening and how he can fix, for example, if we have some error. Also, after accessing the resource, clients should be able to find all other actions they can take. For example, we need to show to the client if it's possible to edit the book, delete the book, or if he can only get information about this book. All those information needs to be clear to the client. So the next principle is statelessness. Statelessness is a communication method that says that the server will complete every client request independently, and each request will be separated and new connected. So this way, the server doesn't need to restore any previous requests that the client sent, and also doesn't matter the order that the client will do requests for the server. It will always be attended independently of each other requests we have. Our next principle is the layered system. The layered system says that client can connect to other authorized intermediates, and also that the server can connect to any other servers or third-party applications, and those layers will remain invisible to the client. So let's say, for example, our server needs to connect to a third-party application and receive one response from this application. He needs to send the response directly to the client. So the client will not know that this response came from another third-party application. The next principle is cacheability. Cacheability is a way to store information on the client side or on intermediate servers. Our API should support caching so we can achieve highest rates on responses. One example here is when we have a web page, let's say with a footer, and this footer has an image. This image can be stored on the client side. So anytime the client changes the page, he doesn't need to get this image again from the server. This image will be stored locally, and this response will be very fast. This caching is controlled by using API responses of the type cacheable or non-cacheable. The last principle of REST is code on demand. This is an optional principle, so you don't need to have this to have a RESTful API, and it's the ability to send executable code to the client. One example here of this principle is when we have registration forms, and we have, for example, one field for email. If you type a wrong email, you can see that the client will say to you that you are putting wrong email there. This is made using this code on demand principle of REST. So now that we know the principles of REST, the benefits we have when we implement RESTful APIs. The first one is scalability. Since REST optimizes client-server interactions and the server doesn't have to retain past client requests due to the statelessness principle, we can have a high scalability on our application. Also, caching can partially or completely eliminate some client-server interactions, meaning that we can have a lot of users using our application and we can scale it very, very good. The second benefit is flexibility. REST supports that client and server are totally separated. This means that platform or technology can change on the server side and the client will not be affected. This occurs because we have a standard way to communicate and both sides know how to communicate. So it doesn't matter the technology that our server, because the client will know how to communicate with the server. This also leads to the independence benefit. Client and server can be written in different languages, and you also can change technologies on either side without affecting this communication. Because again, we have a standard format to communicate. So both sides will know how to communicate, and it will be independent of language or technology both sides are using. So before we start the next part of our presentation, we have a space for questions, if you have any.
Yeah, we invite you to leave your questions in the Q&A section during Matthew speaks. So we don't have any right now. So let's move forward, Matt.
Okay, so let's continue. The next part I want to talk to you is about RESTful APIs. So when we implement REST principles, we have RESTful APIs. And RESTful APIs are interfaces that two systems use to exchange information securely over the internet. Again, because we are using the REST principles, we are following secure, reliable, and efficient software communication standards. This leads us to a very standardized communication, and both sides will have knowledge on how to communicate between themselves. So how a RESTful API works. We have 4 steps on the communication between client and server on a RESTful API. On the first step, client will send a request to the server. This request can be to, for example, requesting the book information. The server will then authenticate this client, and we will take a look if this client can access this information. If server allows the client to access it, it will receive and process this request, look on the information he needs to return to the client. And the last step will be that the server will return this response to the client on a standardized format. We have on the next slide an image on this communication. So here on the left side, we can see the REST clients on a RESTful communication. Let's say it can be a web page or it can be a mobile application. And those clients will do a REST request to our REST server. They will use one HTTP method, for example, get, post, a put, or a delete, plus the URI. For example, if they want to request the information about the book, they will do a get request to the library/book URI. So the REST server on the right side of the image will authenticate this client and see if it has if it's allowed to access this information. If this resource is on the server side, it will be represented in some standard pattern like XML or JSON, and this response will be sent again to the client. So those are the steps on this communication. Now that we have the example on how to communicate, we need to know what methods we can use on a communication. For example, the get method is used when the client wants to access resources on the server. Again, using the example of the library, if we want to access the book information, we need to use get method. Otherwise, if we want to create or send data to the server, we need to use post method. We also have 2 methods to update existing resource on the server. For example, if we want to change information about the book, we need to use the methods put or patch. The difference between those 2 methods are put method will update the entire resource. So you need to send all information to update it again. Otherwise, the patch method will only update parts of the resource. For example, let's say we want to update the book title or the author of the book. So we just need to send the information we want and use the patch method. The delete method is used, as the name says, to remove the resource from the server. And we also have other 2 methods, and those 2 methods usually are provided by Django REST Framework. The first one is head. Head returns metadata about the resource. For example, let's say if we have an image and the client wants to know the size of the image before downloads it, he can use the head method to get this information without downloading it. And also we have the options method. This method returns a listing of supported and allowed HTTP methods for this endpoint. This is complaining with the previous principle that we saw on RESTful, that is that the client needs to know what he can do on every resource we have. So he can use this options method to get those available methods. Now let's start talking a little bit about how to authenticate our users. The authentication is used to identify which user is trying to access the information. We have 4 types of authentication. The first one is basic authentication. This uses a username and a password, base64 encoded. This is not very secure, and we need to use HTTPS to combine it with this type of authentication. We also can have bearer authentication. This is a bearer token that is an encrypted string of characters generated by the server. It's also not very secure because the token can be decrypted. So we also need to use HTTPS with this method. Another method of authentication is API keys. API keys are unique keys generated by the server to every client. Those API keys also can be stolen, so we need to use HTTPS here too. The last and more secure type of authentication is OAuth, because it combines two types of authentications, passwords and tokens. First, the server will request the password, and then it will request an additional token. Using this method is the most secure way to interact on the web, because if you lose, for example, the password or the token, you still have the other method to protect you. Now that we know the authentication and all the other things, let's talk a little bit about response status codes. When we send a response to the client, we also need to send the status code. Those status codes are defined on requests for comments, or RFCs. They are divided in ranges, and each range identifies one type of response. For example, the range 100 identifies informational responses. The range 200 is used to successful responses. The 300 is used for redirection messages. 400 is used for client error response, and 500 for server error response. Let's take a deep look on each range of these and some examples of messages we can have. On the range 200, we have the success response codes. Those are the most common response codes on APIs, and they means this. The 200 OK means that the request was succeeded. For example, if the user received the correct information he wanted, or something was created on the server side. The methods we have here are just a suggestion to use, because again, REST is not a standard, so you can use any method you want, but the indicated ones are get, head, put, and post. We also have the 201 created. This is used when the request has succeeded and a new resource was created on the server side. This is very useful for post and put methods. The 204 no content is for successful responses, but we don't have any content on the body of the message. So it's very used when we have delete resources, for example. Because you already deleted this resource, you don't have any information about this to send to the client. So you just send a 204 no content, and the client will know that the request was successful. On the next range of messages, we have the 400 range. This is used for client error messages, meaning that the error is part of the client. So the first one is 400 bad requests. This means that the server cannot process the request due to some client error. One example here can be if the client didn't send some information you need to respond, or if the information is wrong on the client side. We also have the 401 unauthorized. This will be returned when the client is not authenticated. The 403 forbidden is used when the client is authenticated, but doesn't have access to this content. For example, if we have a management endpoint, and this endpoint is only accessible for admin users, and a regular user try to access it, we can return a 403. The 404 not found is used when the server cannot find the requested resource. Let's say, for example, the client sent a wrong book information that he wants, and we don't have this book on our database. We can return a 404. The 405 method not allowed is part of the REST principles because it says that the method not supported by the target resource. For example, if the client tries to delete the book or update the book, but we just have methods for getting book information. We also have the 429 too many requests. This is used for rate limiting on the API. Next, we have the range 500, and this is used for server error messages. The 500 internal server error means that the server encountered the situation it does not know how to handle. This is an error you want to avoid, because probably you did something wrong on your code. For example, if you have an untreated exception or something like that, this will be returned to the client, and it will not know how to handle this. We also have the 503 service unavailable. This is returned when the server is not ready to handle the request. For example, if our server is down, the client will receive this error code. Besides the static code, we also have the response message. We have a body on our response message. The body will contain the resource representation, and usually we use JSON, HTML, or plaintext to represent this. The most used one is JSON because it's easily readable by humans and machines. This will be all the information that we have about the research. For example, about the book, we can have the ID, the title of the book, the author, and any other information about the book will be on this body of the message. We also have on the response headers, and those headers are used to give more context about this response. Those headers can include information such as the encoding type, the date, and content type on this response. We also have now another pause for questions. I don't know if we have any.
Yeah, we have one question, Matt. It's from Valdinier. The question is, in the patch method, should we create endpoints for specific fields, or should we receive it in a single endpoint and analyze which field was entered?
Yeah, you only have one endpoint for doing the entire patch, and you analyze just the fields you're receiving on this endpoint. So you don't need one specific endpoint for each field of your resource.
Great, thanks, Matt. Thanks for your question, Valnei. For the moment, we don't have more, so we can keep going.
Okay. The last part of our presentation is about the Django REST Framework. That is a framework of Python. It's a toolkit for building web APIs. So Django REST Framework includes authentication packages for both OAuth1A and OAuth2. It also offers serialization for model ORMs and not ORM models. It's very easy to use and integrate with your Django project. It has an extensive documentation on the internet and also a great community. The first thing I want to talk to you about the Django REST framework are how to create good endpoints. So for example, on the left side here, we have some bad examples on how to create them. We don't need to put the action we want the user to use on the endpoint. For example, we have API/users/create. And we also have the delete user, update user, and list users. And we are creating 4 different endpoints for this. A good way to do this is on the right side. We only have one endpoint that is for API/user, and we are creating 4 different methods here. One for the list users, another one to create users, other to update users, another one to delete users. So what we identify, what the client wants to do in this endpoint is the HTTP method he's using. So for example, if he wants to create a user, he will use the post method. We don't need to have API/user/create because of that then. Next thing I want to talk to you is about keeping your endpoints consistent. For example, on the left side, we have 4 different endpoints for the book resource. One is for user, another one for management, other for library, and one for store. And you can see that we have 4 different ways to identify the book resource. We have books or book. A good way to create your API endpoints is to keep these resource identifications consistent over all your endpoints. So for example, on the right side, we have API/user/books, and all the endpoints identify books as books. So this way, both the client and the developers know how to interact with your endpoints because they probably know how your resources are identified. So remember to keep always a good consistency. You can use, for example, only book instead of books, but keep all your endpoints with the same pattern. We also need to keep consistency on our serializer and models. For example, on the left side, we have 3 different models, one for user profile, another for author, and we also have one model for book. You can see that we have 3 different types of IDs, identification for IDs. For example, user profile use the field ID, author use author ID, and book use UID. On the right side, the other way, we have the same 3 models, but they are all using the same field ID. This is a good way to create your API because this way the client will start to know that every model follows a pattern. And this way your documentation will be simpler and the communication between you and the client will be better. We also have difference on for example, the email address and the address, phone and city state on user profile and author. For example, user profile use email field and author use email address. This difference is bad. So try to keep always using the same type of identification here too. Next, we need to provide clear error messages for our client. This way, the client knows how to deal with the response. For example, on the top of the left bad example, we have a retrieve endpoint. On this endpoint, clients can send an ID, and we will retrieve a user profile resource. You can see that we are returning a 200 OK, but keep a look on the line we are getting the user profile. If this ID doesn't exist on our database, we will probably have a 500 error here because we have an exception that we will not treat it. A good way to treat this is on the right side that we have a try except. And if we don't find a user profile with this ID, we are returning a 404 error. This way the client knows that there's an error because the ID doesn't exist on the database. On the bottom, we have another endpoint for creating. In this case, we are creating an object and we are validating the serializer that the client sent to us. So we are just returning a 400 error if the serializer is invalid. This is bad because the client will not know what's happening. So on the right side, we have a create method that returns also the serializer errors. This way, the client will know that is a 400 bad request because, for example, one field is wrong or one field is missing. So try to keep this in mind when you are developing your endpoints, that you should provide clear error messages to the client. Also, another good thing we should do on our API is our authentication mechanism. This will be used for identifying the client that's trying to access the information. So to add, for example, token authentication, we just need to add to our installed apps configuration the REST framework .auth token. We also need to add this default authentication class to our REST framework settings. This is not the best authentication method. It's just an example on how to do this and why we need to do this. So consider researching about OAuth authentication because it's a most secure method on authenticating. Now that we have authentication, it's also a good idea to add permissions to our views. Since now we know who is trying to access our information, we also can allow or not allow this client to access our views. Django REST Framework offers a nice set of permission policies. You just need to import the REST Framework .permissions package. The 4 types of permissions Django REST Framework offer are allow any. The allow any permission will permit anyone to access your endpoint, even if it's an authenticated user. The is-authenticated permission will deny any unauthenticated user to access your endpoint. But if the user is authenticated, it will not check for any other permission. It will be allowed to access the endpoint. We also have one permission to admin users, that is admin user. This will deny permission to any user unless the user.isstaff field of the user profile is true. So this is very useful when we have the management endpoints, because this way only admins can access this endpoint. And the last type of permissions that Django REST Framework offers is the is authenticated or read only. This will allow unauthenticated users to only access GET, HEAD, or options requests. All other methods we have on this endpoint will be accessed only by authenticated users. Another good thing we could add to our API is pagination on responses. This is useful when we have, for example, endpoints that return a lot of information. So adding pagination, you have less information being sent on each response. So Django REST Framework also provides classes for pagination, and he provides the page number pagination. In this type of pagination, a single page number is accepted on the request query parameters. And also, the client can navigate to any page he wants. We also have the limit offset pagination. On this type of pagination, clients should pass the limit and the offset query parameters, but he also can go to any arbitrary position he wants. The last type that Django REST Framework provides is cursor pagination. Cursor pagination only presents forward and reverse controls. This way, client can't navigate to arbitrary, he just can go forward or back. You can also create custom pagination styles, and we have an example on this. So let's take a look on how to use the types of paginations Django offers. The first one is page number pagination. When you have this kind of pagination, the GET request will be like this. You can see we have here a query parameter page equals 2. This means that the client is trying to retrieve page 2 of the user profiles endpoint. If there is no page parameter here, we always send the first page for the client. To use this, we just need to add to our view the pagination class page number pagination. Client can also send the page size he wants on the response. On this example, he's sending page size 10. This means that we will have 10 user profiles on the response. Next, we have the limit offset pagination. On this type of pagination, the client sends to us the limit and the offset he wants. For example, here, the limit is 15, meaning that we will have 15 user profiles on the response. We also have an offset of 100, so we'll start the response on the user profile 100. To add this, you just need to add the limit offset pagination to your pagination class on your view. The last one is the cursor pagination, and this is a little bit more complicated than the other ones. This type of pagination requires that you have a unique unchanging ordering of items in your result set. It's more complex, but provides a more consistent pagination view. Because let's say, for example, some clients creating a new user profile on the exact moment you are requesting the list of user profiles, you never see a duplicated response here. It also supports the usage with very large datasets because it's very optimized. To use this, use the same way the others we already showed. You just add to the pagination class the cursor pagination. But keep in mind that this cursor pagination as default will order the query by the field called created. If you don't have on your model a field created, this type of pagination will not work. You have to customize this. On the next slide, we have an example on how to customize the cursor pagination. So if you want to customize the cursor pagination, keep in mind that the ordering field should satisfy the following restrictions. The value you want to paginate should be unchanging. such as timestamp, a slug, or any other field that is only set once when you are creating this object. Also, this value should be unique or nearly unique. For example, timestamp can repeat, but for timestamp, cursor pagination deals with that for you. We also should have a non-nullable value here, and this value should be cursed to a string. Also, since the problem with precision problems, it can be a float. If you want to use a float field to order and use cursor pagination, you should take a look on the documentation because they suggest to use decimals and they have an example on how to do this. Also, the last restriction we have here is that this field should be indexed on your database. So I have an example here to ordering for a field that is created at. I'm using here the descent order, and I'm just inheriting from cursor pagination and creating my cursor pagination. On my view, I'm using my new pagination that I previously created. So here the next line and see the second page of this response.
Sorry, Matheus, I think we lost you for a moment. Now we are right.
Okay.
Do you hear me? Okay.
Yeah. Are you hearing
Sorry.
me?
Yeah. I think we can hear you.
Okay. So I will repeat this. In this slide, we have an example on the cursor pagination response. You can see that we have the next and the previous links. So to go to the next page or to the previous page. In this case, we don't have a previous link because this is the first page of our pagination. On the next slide, we have an example if you use the link here on the next key. So here you can see that we have the next and the previous links. This is the continuation of the previous response, and we have different results here. If you use the previous link here, you go to the exactly same page we had before. So we also can create custom paginators, and this is the way we can do this. You can see on the left side, we are creating a my page number pagination that inherits from page number pagination. Here I'm changing the page size parameter to 2, meaning that I will only have two resources on the response. I'm also changing my page size query parameter. This is how the client can change the page size he wants. Here you can put any name you want, but again, keep in mind that keep it consistent over all your API, and put a username for the client here, because you have to have this documented because the client needs to know how he can change this. I'm using the same page size parameter that Django uses just to keep it consistent. I'm also changing the max page size here to 10. So here, even if the client sends to me that he wants 100 responses on page size, I will just send maximum 10 for the client. I'm also changing here. Hold on. I'm also changing here how the paginated response looks. I'm putting the next and previous links nested on a links key. So you can see on the right side how this pagination will look on the response. I have on the top nested on a links, the next and the previous link. In this case, it's the first page. I also have the count and the results. Okay, now you can pass the slide. This is how we can set a default pagination class for all endpoints we have. We need to configure our settings, our REST framework settings, and we need to add those two settings, the default pagination class will be the pagination we want to use. In this case, I'm using the REST framework pagination, page number pagination. You can also define here the page size you want as default. In this case, I'm using 100. But if you create your own pagination and wants to use it on your API, you should do like we are doing on the bottom image. In this case, I'm setting the default pagination class to use my page number pagination. Here, my app identifies the name of my application, and the pagination is the file where I created my pagination class. And my page number pagination is the name I give for this pagination. I used pagination to keep consistent with Django REST Framework pagination. I'm also changing here the page size for 2. So when I'm using this class pagination, only 2 results will be sent to the client. Another thing I want to talk to you is about throttling. Before I start, keep in mind that the throttle provided by Django REST Framework is not intended to be used for security requests. It's only available for control the rate of requests on your API. So throttle will determine if a request should be or not be authorized for a client, and it will be a temporary state. For example, if the client repeats the same request after some time, this can be authorized if it was previously denied. As I said, it's used to control the rate of the requests, and the provided ones by Django REST Framework are the annual rate throttle. It's used for unauthenticated users, and it will use the IP address of the request to verify this. We also have the user rate throttle. This is used for authenticated users. Django will take the user authenticated on the header and use this ID to identify who is trying to access the information. The scoped rate throttle is one type of throttle that can be used for specific parts of the API. So you can change what parts will be using the throttling or no. And you can also create custom throttles, and the documentation of Django is very good on how to do this. So here's an example on how we can setting a default throttle class to policy to our application. We need to add on the REST framework settings the default throttle classes we want and a throttle rate for those classes. For example, here I'm using 2 types of throttling. One throttling will be used for anonymous users and another throttle for authenticated users. So you can see anonymous users will only can access 100 endpoints per day, and authenticated users otherwise can access 1,000 per day. We also can set this throttle policy per view. So for example, if you want one endpoint to have one kind of throttle and another one to have other, you can set the per view. In this case, you just need to add the throttle class you want to your view. In this case, I'm just throttling anonymous users. It will use the parameter you set before for the rate you want for this case. Here, for example, in this list user profile, you can only access 100 times per day. Another thing important, as we already discussed on the REST principle, is to use cache. Django also provides cache frameworks, and you can use a lot of cache types. For example, you can use the memcache. Memcache is a memory-based cached server, and you need to have one server running one cache to use this one. Redis is an in-memory database that can be used for caching. For using this type of caching, you also need your own Redis server running to use this. The database caching will store the cached data in your database. So Django will do this using your database. To use this type of caching, I recommend you have a good database, very indexed and very fast, because otherwise your caching will not be very efficient. We also have the file system caching. On the file system caching, Django will serialize and store each cache value on a separated file on your file system. This way, instead of accessing your database, those values will be retrieved from these files. Another type of caching is the local memory caching. This is the default cache if you not specify another one, and it works like the mem cache, but in this case, Django will use the local memory for caching the data. So you don't need your own server to run the mem cache. And the last type we have is the dummy caching, and it's used only for development. It just implements the interface and it doesn't do anything. It's just used so you can test your application. You can also use an external cache backend with Django, and the documentation is very good on this. If you want to use a different one, I recommend you to take a look because it's very easy to use. So here we can see how we can configure and apply the cache on our application. The first thing we need to do is configure the caching under setting files. We do that adding this caches dictionary. In the default key, we add the type we want to use. In this case, I just used the dummy cache since this is just an example for this presentation. Once we set up these settings files, the simplest way is to cache the entire application. So to do this, you just need to add those 3 middlewares to the middleware configuration. And this way you have the entire application automatically cached by Django. But let's say you don't want to cache your entire application. You just want to cache some views. You can do that caching per view. In this example, I am using 2 different caches. One is for list and another for retrieve. Also, I'm using here a vari header. This can happen because let's imagine our page have, for example, different languages. So we need to store this page on the caching, taking into account that different users can have different languages. So Django offers these decorators for variant headers. In this case, I'm using the variant headers for authorization on the retrieve endpoint on the bottom. This will define that which request headers the cache mechanism will take into account when building the cache key. Also, since it's too common to vary on cookie, Django has a decorator only for this. And I'm using this on the list endpoint we have here. So you can see I'm using only the vary on cookie. So we talked a little bit about how we can implement the REST principles on your APIs using the Django REST framework. And now we can have space for questions if you have any.
Let me check chat. The chat is clear, and the Q&A, it's also clear. No, I think we don't have more questions, so we can move forward. Oh, yeah, there is one.
That's
there
it.
There is one.
Okay, okay.
Carlos is asking, are there standards to catch with Redis?
Sorry, can you repeat? Because I didn't hear you.
Are there standards to catch with Redis?
Oh, yeah. You can check the Django documentation because it's a little bit more complex than we can present here on the webinar. But yeah, you can check the documentation. You see that they have a proper way to do this.
Great. Thanks, Carlo, for your question. I don't know if there is one more. No. Well, okay. Thanks, Matheus, again for presenting and preparing this webinar. It was great. Thanks everyone for joining. Oh, we have another question. It says, where can we see the best practice in writing REST APIs in Django?
Where we can see what?
Where can we see the best practices in writing REST APIs in Django?
Yeah, This is a little hard to find because there's no rule for this. You know, it's a thing you can research. For example, you can take a look on the REST principles, and then you can try to apply this to your APIs. But there is no guideline for this because each people can create your API in your own way. So there is no thing like a cookbook for this. You need to take a look on how REST rules, REST principles are implemented and follow this on your application.
Great. Thanks, Matheus. I think now, yeah, I think we don't have more questions. Well, thanks everyone for joining. If you want to watch this webinar again, you will probably find it in the following weeks in our YouTube channel. So you can follow us, it's BEON.tech. So, well, thanks again.
Thank you, Ben. Thank you, everyone.
Bye-bye.
Bye.